Hey everyone, thanks for reading my research paper. Today I'll be talking about the bidirectional integration of artificial intelligence um, and cyber threat intelligence. So, how AI affects cyber threat intelligence um, in the industry, how it's going to grow, um, and how there can be a bidirectional relationship between AI into threat intelligence and threat intelligence into AI. Um, so let's get started. So just for some context, AI is currently transforming how cyber threat intelligence is gathered, analyzed, and shared. As we know, it's affecting lots of areas within cybersecurity and outside of cybersecurity. It's transforming, all of our industries as a whole. So AI is definitely being used in CTI and how it's gathered, how it's analyzed, and it's how it's shared amongst the cyber community. The problem that we have currently with CTI and especially with AI is that current systems, current cyber threat intelligence systems, they use AI one way. So they will consume data to give you results, but they will not continuously learn, right? AI is rapidly changing how threat actors, um, how what type of attacks they have, what type of threats exist, what type of vulnerabilities exist. Um, in many different cases, right? Whether it be phishing, malware, social engineering. There's crazy ways how AI is even used to kind of shift videos and photos to steal identities. So all of this to say, um, you know, AI is currently being used in threat intelligence to consume that data and give outputs, but it's not fast enough uh, to kind of adapt to the continuous changes that threat actors are using, especially with AI. So the goal is to make AI a contributor to cyber threat intelligence via feedback loops. So it's continuously improving the same way the threat actors are using AI to continuously improve different types of attacks. So why do we need bidirectional AI and cyber threat intelligence? So we know that artificial intelligence enhances cyber threat intelligence analysis, but models drift as adversaries adapt, right? So a way you could think about this is in the example is imagine a malware classification model that slowly becomes less accurate as attackers continuously modify payloads, right? So if there's a malware classifier that slowly stops detecting new variants, in today's systems, analysts they have to like manually notice a drop in accuracy and manually update their rules or whatever configurations and detection rules they have, right? um, the way that this works is that it's reactive. It's very reactive. It's manual. There's slow updates based on what type of modifications attackers are using. A bidirectional AI CTI model would detect that drift automatically, right? They would detect changes. They would be able to publish alerts to CTI, and they would be able to retrain triggers and configurations in order to make the CTI process more accurate and efficient. Um, currently there's no feedback path for AI to publish what it learns. It's always something that has to be understood manually and analyzed manually by an analyst and then implemented. So a bidirectional AI and CTI relationship is needed for this. Here's the hypothesis. So bidirectional intelligence exchange between AI and CTI, where AI both consumes and contributes intelligence, improves detection accuracy, adaptability, and adversarial robustness compared to unidirectional pipelines. So what are some of the supporting concepts for this? So AI becomes both consumer and producer of intelligence. So um, you're using AI to bring in data, but then you're also using AI to understand that data. It's kind of like AI inception. You're kind of using AI to also understand that data and make your existing models better. So there's continuous retraining and model drift detection, and there's integration with Stix and Taxi for standardization. If AI can feed intelligence back into CTI repositories and learn from updated data, it can respond faster to evolving attacks rather than static or one-way pipelines. So here's some related research. What have others done? You'll see from my paper, StixNet, Zero CTI, CTI Nexus, CTI for AI. These are all CTI tools. Most current research automates CTI ingestion, so there is automation, but it doesn't feed the model detections back into CTI, right? So none of these systems currently support continuous feedback or automated retraining. For a variety of reasons. It could be quite expensive. There's also, worries of accuracy and um, AI hallucination could impact accuracy of what your CTI detections are creating. And from a business standpoint, that could be a lot of problems, right? You could totally miss something. There could be inaccuracies, misallocation of resources. There could even be a waste of money for firms, right? But these are some of the studies that were done. um, you know, there was a focus where there was a focus where 6 objects were extracted from CTI reports. This was unidirectional. Zero CTI. This was a recent study that had a zero shot entity and relation extraction that had no feedback that was added to it, to the existing CTI models, and CTI Nexus and CTI 4AI. CTI 4AI had like sharing AI specific threats, but it wasn't operationalized within systems. And there was a LLM-based CTI knowledge graphs, but it lacked readaptive training. So how would this be implemented? What would this look like? The architecture works as a feedback loop. AI models ingest CTI, they detect anomalies or adversarial trends, and they send validated alerts to CTI, which then re-triggers retraining, right? So this is how it would be implemented. There are 4 key layers. So one, AI-driven CTI extraction. So NLP and LLM models, they process reports and indicators of compromise, right? 2, there's adversarial detection feedback. This is a very important aspect, where they detect model drift and poisoning and anomalies. So this is where they kind of detect where there are anomalies and outsiders that current detections aren't catching. And once they realize that a model has drifted or a model is not catching something, it'll be able to go into step 3, right, and perform some adaptive retraining. So automatically update AI CTI models to redirect or reconfigure existing detections. And step 4 is validation and scoring. This is how you know that the model is working appropriately, and making sure the model is reliable. So this ensures reliability before CTI ingestion. So how can this be implemented? There was a setup or some examples that I used pulled from online that of some firms that have been working on this currently. So there were 3 synthetic CTI datasets: indicators of compromise, unstructured reports, and adversarial samples. And the tools that people were using were Python, scikit-learn, PyTorch, and a simulated Stix or taxi repository. The evaluation metrics were precision, recall, and F1. Adversarial robustness, and intelligence freshness. So we evaluated 3 configurations: static ML, unidirectional AI CTI, and our proposed bidirectional AI CTI under simulated adversarial and temporal drift conditions. Each configuration, it was kind of stress tested against evolving CTI datasets and adversarial samples to measure the adaptability and intelligence freshness. So the way the workflow worked was there was a baseline model, there was a static model that was trained once, and we had a one-way model where it consumed cyber threat intelligence, but there was no feedback. In the bidirectional model, there was feedback and adaptive retraining. So the CTI models were improved based on that two-way loop or two-way connection. And then we measured detection accuracy, robustness, and updated time on how the speed was, in understanding what the AI models detected. So here are some of the findings. So you can see the F1 scores, the robustness, and update latency. So you can see that under a static model, right, there's 18% robustness, pretty low F1 score, and a 48-hour, 2-day latency. So this is just a static model without uh, any AI integrated. In the unidirectional model, we see a big improvement where there's 37% robustness, and F1 score increases to 0.81, and there's a 16-hour latency. So the latency has dropped a lot, and you can see how the CTI is learning from the AI. And in the bidirectional model, we see the most success where, in the retrained CTI model, there's 6 hours latency, 59% robustness, and F1 score of 0.9. So definitely an improvement. Um, so each configuration. Here's some trade-offs and limitations. So the pros, there's improved adaptability and faster updates and continuous learning from new intelligence. The cons, there's a much higher compute cost from retraining. There's the need for validation to avoid false intelligence because, the AI models could get poisoned, they could hallucinate, they could give you inaccurate information. And, trust and provenance are still open challenges, because at the end of the day, you need to make sure that accuracy is kind of the name of the game. So that could be some blockers. Some of the next steps in future work, this next phase involves operationalizing this concept, which I believe a lot of firms will work towards, building a prototype that integrates with real CTI models, standardizing trust metrics, and enabling explainable, auditable feedback loops. So next steps in future work are, develop a trust scoring for AI generated reports, extending 6.2.1 to include AI metadata, um, exploring explainable AI to improve analyst confidence, right? And I guess training analysts to be able to use AIs, maybe even bringing some AI engineers into the CTI world, integrating real world threat feeds and benchmarks for testing, and publishing results with an open source prototype. In conclusion, bidirectional AI CTI integration can fundamentally change how we defend against evolving threats, transforming CTI from static intelligence sharing into a living and adaptive system. So bidirectional AI CTI integration treats AI as both a consumer and a contributor. There's continuous feedback that boosts detection accuracy and resilience. There's key innovation, which is adaptive retraining and real-time intelligence sharing. And in the future, I see standardized trust and explainability for AI-generated CTI as AI continues to improve. And as threat actors use AI, you could definitely expect that cyber intelligence teams to also leverage AI to their use. I hope you found this presentation interesting. Thank you.